Next we have exercise 10. Please try to solve it yourself as a homework. There is nothing really difficult to solve. It's just you need to remember what are the formulas for nominal and real GDP, and then you just compute the nominal growth and the real growth, and then you compute also the deflator that is going to show the inflation rate. So then we move directly to exercise 11. And so this exercise is also pretty basic. We will just have to calculate lots of things. So we have a table in which we have 3 years, and for these years we have GDP, which is a nominal GDP, and a real GDP with a base year 1990. Okay, so we have point A. So we see here that in 1960 and in 1974, we see that the value of nominal GDP is smaller than the value of the real GDP. So basically the numbers that we see on the left, they are smaller than the numbers that we see on the right. But we observe exactly the opposite in 1997. So indeed here, number on the right, so real GDP, is smaller than the nominal GDP. So just the opposite. And then the question is why? And so in order to answer, you need to remember what's so nominal GDP, basically it was calculated for, so this one here, it was calculated at the prices of those years. So 1960, 1974, and 1997, okay? But when we have that real GDP, it was calculated actually always at prices of 1990. And so I will just write here. So basically what we have is that, so in the first case, we have that GDP nominal is smaller than GDP real. I will just put that it's 11 and 8 and A. Okay, but what we have here is that actually the price of 1960 is smaller than price of 1990. Okay, so basically we have here that here GDP, so like the prices first, the prices at which nominal GDP was calculated. So before, like long time ago, the prices were much smaller than now. And you need to remember that prices increase over time because we always have inflation. And so prices in 1960 and 1974 were much lower than in 1997 or in 1990, okay? And so basically here GDP, we know that GDP, that's price times quantity. Oops. That's price times quantity. And so here in 1960 and 1974, these prices were much smaller than prices of 1990, at which real GDP was calculated, okay, for these years. So that's why these values here on the left are much lower than those on the right. Okay, so that's actually the reason here, because we have that the prices at 1960 or 1974 are much lower than prices of 1990, and so as components of GDP, they kind of draw the value of GDP down. And then we have just the opposite. We have that GDP nominal of 1997 is bigger than GDP real of 1997. And here, so we have this because of that, and here we will have it because we have just the opposite. The prices of 1997 were bigger than prices of 1990 because prices always grow. And so here basically we have that when the real GDP was calculated, it was calculated at 1990 prices, and here we have 1997 prices. And so here just the opposite. So 1997 prices were much bigger than 1990 prices. I mean, much or not much, but still. And so we have that they contributed to the to this price, so it was higher in nominal GDP than in real GDP. Okay, and that's why we have exactly the opposite here. All right, then we have point B. And here we will have to fill out the last column of table 1. So here we just have to calculate the deflator. And for this you need to remember the formula of deflator, which is just the nominal GDP over real GDP for some year. And so here basically we have to take this value and divide by this value to get deflator for 1960. And so it's just going to be 22.66 if you also multiply it by 100. Then to calculate for 1974, you just take again the first value, so nominal GDP for that year, and you divide by the real GDP for that year. Again, you can multiply by 100, and then you will get this value. And for the last one, again, you take the value on the left, you divide by the value on the right, and you see you will get this value. So from the values of deflator, you can also actually see that, so here, these two, they're much lower than 100, and 100, that will be of the base year, which is actually 1990. So we see that actually kind of how low it was comparing to the year of 1990, and we see that this one here, how much bigger it is again comparing to 1990. Yeah, and here we talk about the prices. So how much prices differed comparing to year 1990. Then we have point C. We have to compute the average yearly inflation rate between 1990 and 1997. So here I'm going to do it on a separate page. And so basically for this one, we just have to know what's the inflation rate. So that's just, so we know that inflation rate is just represented, so I will just write C, is just represented by the deflator. And so basically to get the inflation over the whole period, so like so inflation between 1990 and 1997 is just going to be, have to take deflator that we calculated, you divide by 100 and then minus 1, and so it will be around 18% for this entire period, but we have to calculate the average inflation. And so here it's going to be again the geometric average that we already saw during the previous exercise session. So we will just express, so basically what's the inflation? That's the increase in price, okay? And so inflation between, let's say, so period t plus n and t, so basically here it can be, so this one here can be 1997, and here it can be 1990, okay, so between these two periods. But the idea here is that, so the inflation between the two periods, even if these are not two consecutive years, so just two periods in time, that's just the ratio of the prices in these periods, okay? And so then actually you can have this inflation here for the whole period, let's say between 1990 and 1997, as a combination of the inflations between two consecutive years over the whole this period, okay? So let's say between 1990 and 1991, and then between 1991 and 1992, and so on and so forth, okay? And these inflations together are going to give us the inflation for the entire period, or vice versa. So here we can just express it like that. So basically, so that's kind of the two last years, let's say 1997, 1996, and then times, let's say here, okay, and then we can continue like that. So here it would be, let's say, 1996 and 1995, and so on and so forth, and we come to the first two periods, which is 1990 and 1991, for example. So you see the idea. Basically we can express it like that, and then each of them actually is going to be the inflation rate. So the rate of inflation I will just express here, I will just denote it here by P, and so that's the inflation rate for the year t plus n, basically between these two periods, and then this one here, that's the inflation for the previous period, and here we have the inflation, let's say kind of between the first and the second period, and so on and so forth. And so then actually we can, just to show the idea, we can actually assume that this inflation rate is the same over the whole, I mean, like in all years in this period of time. So between all the years here we have the same inflation rate of some constant p. And so in this case you see that here we have multiplication of all of them. And so basically if p is constant, then here we can just express this all as 1 plus p to the power of n, where n, that's the number of years, and then that will be exactly this first here, okay? And so from here we were doing this to derive the formula for geometric average. So that's what we have seen during the previous session. So basically we can calculate the inflation, so the average inflation between any 2 years during this whole period between 1990 and 1997. If you just take this and you rearrange, you will get this expression. And so here then we can substitute. Actually, we are going to substitute the inflation rate that we got here, because that's exactly the inflation between, like for the whole period, and that's what we need here. So here that's 1.18 because we have 18% inflation, and here 1/7, and that's because we have 7 years between 90 and 97, and minus 1, and so here approximately it will be, which is approximately 2.39%. So basically having that the inflation over the whole period 1990 and 1997 means that the average inflation between any 2 years during this period was on average 2.39%. Okay, that maybe was the most challenging part, but here you just need to know how to take the arithmetic average. And then in point D, we have to compute, so show it here. So we have to compute the growth factor of nominal GDP between 1960 and 1997. And so that's very easy. For this, you just need to know what's the growth factor, and at the end of the slides on chapter 2, you have here the formula about growth factor. So we just are going to apply this formula. And I'll just write here. So we have growth factor of, so basically between 1997 and 1960 of nominal GDP, we just have to take GDP, nominal GDP of 1997 and divide by nominal GDP of 1960, and that's basically it. So we just have to take okay, maybe I will let this one be. And so we just have to take the value of nominal GDP of 1960. So first we take for 1997 and we divide by 1960, and we will get the growth rate. So we just substitute the numbers. And we get that it's 15.527. Then in the next one, we have to compute the growth factor of real GDP between, again, these 2 years. And so the only difference is going to be that you will have to take the real GDP of the 2 years and just divide, so 97 by 60, and you will get the growth rate. So sorry, not growth rate but growth factor. So here we have GDP that is nominal, here we have GDP that is real, and so we just have to take real GDP of 1997 and divide by real GDP of 1960. And we get 2.95. And then the next one. So here from answers to questions D and E, we have to deduce what was the growth factor of prices over this period between 1960 and 1997. So first, for this we need to show what is actually the growth factor of prices. So just using the same formula as we used here in point D. So growth factor, you just take the value of prices of 1997 and you divide by prices of 1960, and that's it. So we have growth factor of prices over the whole period. We can get it if we do something like that. And then basically the question, how can we extract this ratio from our points E and D, basically from the GDPs and inflation that we had. And so we can just take the nominal GDP, so the growth factor that we had, the growth factor of nominal GDP over the whole period, and we just show, so you just know that GDP, nominal GDP, is evaluated at the prices of those years. Okay, so that's just the prices 1997 times quantity 1997. Okay, so that's GDP at current prices, and the same for GDP at 1960. Then we do the same for real GDP. So real GDP 1997, 1960. Okay, so that's the growth factor of GDP over the whole period that we found in D. And so here again we can just represent it as so basically we know that it's real and it's evaluated at prices 1990, so it means that we have prices of 1990 in the calculation of this GDP. And so here we see that actually we can cancel out prices here, and that's indeed what real GDP shows to us. It just shows, you remember, the change in the quantity produced only, and that's it, what it shows. Okay. All right. So, and then actually we can combine these two together. So if we take the growth factor of nominal GDP over the whole period, and we divide by the growth factor of the real GDP, again for the same period, what we are going to take actually is this one. Okay, I don't know why it doesn't write. Okay, now it writes. So actually we take this one and we take this one. Okay, and so we just rewrite it here. And what we are going to get here is that actually when we divide the first one by the second one, it's kind of the same as to multiply the first one by the inverted second one. So it will be like that. Okay, and once you do it, you see that you can actually cancel out this one here and this one here. And so when you divide the growth factor of nominal GDP over the growth factor of the real GDP, you will actually get the deflator. So you will get, sorry, not the deflator, but the price growth rate. So that's actually what you get. And that's 15/3. So it's approximately 5. And from here we can just make a conclusion that the growth factor of prices between 1960 and 1997 is around 5.